Hello, and welcome to the May webinar from the IEA Clean Coal Centre. My name's Stephen Mills, and I'm a Senior Analyst and Author at the Centre. Our monthly webinars are based on our technical reports, which are available from our website at www.iea-coal.org. After one-off registration, residents of member countries and employees of sponsoring organisations can download our reports free of charge. Please take a look at our website for further details. Now we come to today's webinar. Now, you often hear the term modularisation, but what exactly does it mean in the context of developing a power plant? Well, it can be used to describe various aspects of design and construction, but in essence, it's the process of breaking down something, either digitally or physically, into smaller parts that can then be reassembled in their final form. Now, in the first part of today's presentation, I thought we'd take a look at the increasing use of modularisation and how and where it's being applied, mainly in the development of more conventional coal-fired power plants. We'll consider some of the benefits and challenges that can be involved in its application. In the second part, we'll look at some promising ideas and areas for the future. So, as we just heard, there are a number of similar sounding terms often bandied, such as these. They're being used increasingly and often interchangeably, although depending on the particular application, they can have subtly different meanings. So in some cases, modularisation might refer to a specific plant part or system, whereas in others it might be the design of all or part of what's essentially a complete power plant. But in essence, the basic principle covers the breaking down of a system or part of a system into smaller elements. Now, in the case of a power plant, it's generally the process of converting the design and construction of a monolithic plant into one that enables major modules to be developed and fabricated off-site in a supplier's factory or workshop. At the right time, completed modules can then be transported to the worksite for final assembly. And this type of construction contrasts with conventional techniques where a plant is largely field-erected. It's usually referred to in the industry as stick-built assembly. Now, although 100% modularisation is rarely a practical proposition, and the extent of its use can be limited, it can be very useful in reducing capital investment costs as well as shortening both development and construction timescales. As we'll hear shortly, under the right circumstances, it can be very effective at doing both. Now, modularisation has been instrumental in driving many aspects of technological development and bringing in innovations and new skills into many areas of engineering, design and construction. This has led directly to improvements in plant safety, quality and efficiency. Its use has been growing steadily, but there can be practical limitations. Despite efforts to standardise power plant design and production, no two are completely alike. There are going to be some site-specific variations that can include things such as coal type, physical location and so on. The past few years have seen a trend for unique one-off designs to be replaced, at least to some extent, by those that make a greater use of standardised, pre-engineered, pre-designed, prefabricated modular components and systems. And by way of example, the FGD plant shown here under construction is just one where modular techniques are being applied widely. Several hundred of this type have been built around the world, and modularisation is becoming an increasingly important part of that process. Now, when it actually comes to building a power plant, producing parts and systems away from the work site can provide important manufacturing and cost advantages over assembly in the field. One of the biggest is that manufacture is carried out under controlled conditions. In other words, it's not affected by the weather and other outside factors. And largely to control costs and timescales, the power sector has been moving more in this direction. Now, the main advantages cited can include some, or even all of these, most of which are self-explanatory. So these are some of the possible benefits, but how does this impact on project costs? Well, modularisation can be useful in this respect. For example, it's sometimes possible to simplify a particular system, saving money both on design and equipment. And it's not uncommon for something built off-site in a module shop to cost perhaps 15–30% less. It also cuts down the need for skilled on-site workers. They can often be replaced with locally sourced labour, which is often cheaper. So it all sounds good, but as with most things, there can be downsides. At the outset of a project, one of the first and most important decisions will be just how large are any modules going to be. As they get bigger, so do the practical difficulties of actually getting them to the worksite. There might also be financial implications. The cost for a first-of-a-kind module can be higher as more upfront engineering might be needed, and potentially this could push up costs by perhaps 10 or 15%. But of course they're likely to be less for any follow-on units as the detailed engineering work's already been done. Similarly, procurement might be higher for the first unit. And finally, as it's common practice to pack modules tightly with equipment, there can sometimes be problems as units age and maintenance or servicing becomes more frequent. In other words, it can be more difficult to physically get into them. Now here's an example of just how modularisation has been used on a major project. This is the PRAIRIE State Energy Campus in the USA. The plant was built by Bechtel, and like most other developers, they tried to incorporate as much modularisation as possible into the plant. When it came online in 2012, it was the largest greenfield coal-fired power plant built in the USA since the early 1990s. And modularisation played a key role in many aspects of its development. Its use was critical in controlling labour and project requirements and costs, and it also eased problems of getting materials and components to the site, a lot of which were moved by road or rail. Many plant systems were fabricated off-site using modular techniques, and these are just some of them. It all clearly worked, as the plant is still one of the cleanest and most efficient in the USA. And Bechtel are clear that the use of modularisation played a major part in achieving this. Now let's look at some specific applications where modularisation can make a useful contribution. Well, modular construction has been applied increasingly to coal handling systems used for conveying, crushing, screening and so on. An increasing number of these systems are being built using standardised modular sections that allow them to be supplied and assembled and even reconfigured faster and more cheaply than more permanent structures. For instance, there was a recent example in South Africa where a modular coal processing plant was delivered, installed, commissioned and running within the space of only a few weeks. Now, if we take coal washeries as an example, well, modular plants are now offered commercially, and the concept of building them largely from pre-assembled modules has been gaining ground steadily within the sector. And this picture shows an example of this. This is an advanced modular lignite washery under construction in Turkey. Now, compared to earlier systems, modern self-contained modular prep plants, such as this, can provide the usual benefits such as lower capital costs and rapid installation, but also things like lower water and power consumption, more flexible operation, smaller footprint, and better rates of coal recovery. The modular design also means they can be relocated quickly, and it also allows them to be modified and updated more easily than their more permanent predecessors. And just before we leave coal supply and processing, I thought these were interesting. Coal handling and storage domes built a few years ago for the Italian utility Enel. They're based on a unique prefabricated modular construction system that simply bolts together. So assembly is fast and the need for on-site welding or fabrication is virtually eliminated. The techniques also apply to structures used for instance, the storage of gypsum for tea plants. Now let's move on and look at some actual power plant applications. Well, some modular techniques have proved to be well suited to power plants, although as we've heard, the extent of their application can vary significantly between projects. Compared to, say, a gas-fired CCGT plant, where these are often smaller and less complex. And with coal plants, it can be more difficult to modularize them to the same extent. There are likely to be more variables involved, and this can clearly complicate the process. There are many parts of a typical coal-fired power plant that have benefited from modularisation, and this can extend from initial coal handling that we've just touched on, through the combustion process, right through to the back-end emissions control systems. Now, from a purely practical perspective, it's unlikely that a complete power plant, particularly a large one, in its entirety could ever be fully modularised, but there are quite a few opportunities throughout much of the system. And in recent years, this is a concept that's been taken up in some shape or form by most of the major technology providers and plant developers. Now, in some cases, because it can offer certain benefits, the use of modularisation has encouraged developers to opt for the use of identical smaller capacity units, operating in parallel, instead of a single large one. This sort of approach can allow overall capacity to be increased incrementally, as well as help reduce technical risks. So, in the event of a plant failure or unplanned outage, one unit can be taken offline as opposed to shutting the entire plant down. The idea has been applied to projects in, for example, India, where quite a few industrial users and power generators have opted to go for several identical units instead of one larger one. And perhaps one of the biggest examples of this is a major petrochemicals plant that operates no less than 9 matching CFB boiler plants used for on-site steam raising and power generation. Now, modular design and construction techniques can be applied to different types of system used to control plant emissions of the usual pollutants, such as SO2, NOx, particulates, and mercury. But if we take SO2 as an example, well, various designs of FGD plant are available from technology suppliers, and increasingly, modularisation is being used in their design and construction. Some types of scrubber are now available in largely pre-engineered form, often made up of a number of major modules such as ductwork, absorber modules, vessel assemblers, and so on. And by way of an example, this is Doosan Lentje's FGD plant under construction. More than 200 units of this type have been installed around the world, and modularisation and standardisation has played an increasingly important role in this. This hasn't been limited just to Doosan, as many other major manufacturers have also followed this route. Advances and new developments continue to be made in the area of emission control in general, and wherever practical and cost-effective, these often feature modularisation in some way. The advantages often cited for the use of modular design and construction include the usual things such as compactness, ease of maintenance, reduced assembly and labour costs, plus rapid assembly and easy transportation. All useful items for plant developers and builders. And just before we move on, well, we've said a lot about modules, so these can range from quite small assemblies through to items such as this. I thought I'd show you just how large a single module can actually be. This is the largest heat recovery steam generator built remotely in the USA. It's 125 feet tall and weighs in around 4,000 tons. It's shown here on its way down the Hudson River in 2017 to a new power plant in New Jersey. It was itself built up from 10 smaller individual modules. Building the unit in modular form in this way saved money and crucially also reduced construction time by about 7 months. Now let's look at some interesting ideas for the development of small-scale modular power plants. Well, there's a general perception that to be efficient and cost-effective, coal-fired plants need to be big. However, this may not always be the case, and in some situations, smaller capacity units are more suitable. In some countries, these are already used quite widely, and some are based at least partly on modular design and fabrication. Many are in Asia, where they provide power to local communities or operate as captive power plants at commercial and industrial sites. Now, even where coal already provides a significant proportion of the country's electricity, there are often perhaps more remote regions that still lack a reliable, affordable supply. In some cases, there might not be enough local demand to justify developing a large power plant, so a small unit is more appropriate. This can tick all the right boxes. As an example, this has been looked at for parts of Indonesia, and these are some of the benefits that were identified. Using small coal power plants in this way can boost local economies and help attract other commerce and industry into the area. In fact, Indonesia already has a history of using smaller capacity units, many providing power to island communities where electricity generated by diesel plants is often twice or more the cost of that from small coal-fired units. And even in the USA, where you might least expect it, a new 17-megawatt coal-fired cogeneration plant was recently built in Alaska. This relatively remote location lacked access to natural gas or oil and had only limited potential for renewables such as solar and wind power. And after evaluating no less than 13 different design options, coal emerged as the winner by far. Using diesel would have meant that electricity would have cost 6 to 7 times that of coal, while natural gas would have been 4 to 5 times higher. But the use of smaller capacity units isn't necessarily limited to remote locations or developing economies. For instance, coal-fired plants provide around a third of Japan's electricity. When the country's power market was opened up in 2016, quite a few developers opted to go for small coal-fired power plants, and these are now in operation or being built by various power companies and industrial users. Similarities in design and construction meant during development, some plant elements benefited from the use of modularisation techniques. So, modular construction can be particularly suited for smaller plants, as their size allows a high degree of shop printing and assembly. It also means that developing and building plants at sometimes remote sites can be made much easier. Now, another low-risk benefit of using smaller plants is that if needed, capacity can be increased incrementally, simply by adding further identical units. This is an option that's frequently been used in India, for instance, where a lot of smaller capacity units have been supplied by BHEL, and wherever possible, they've increasingly gone for modular design and construction. Operating multiple units rather than a single large one can provide a high degree of operational flexibility that can help keep plants operating under optimum conditions. And also because units all use the same technology, operators get very familiar with them. And finally, even if a single unit has to be taken offline, it's often still possible to meet demand. Now, in the USA, the Department of Energy is looking into the development of small modular coal-fired power plants. As part of efforts to retain coal for power generation in the future, the DOE has instigated a program looking into the possible use of such plants, and as part of this is providing funding for 2 or 3 small modular designs. Potentially, these could have a significant impact on parts of the power sector. The DOE is looking at potential markets for modular plants of between 50 and 350 megawatts, with an eye to markets both within the USA and overseas. Initial designs have been requested and should lead to the development of cost-competitive small modular plants that are efficient, operate flexibly, react quickly to changes in demand, and produce very low emissions. They'll also be expected to have the capability of operating at low load, have low water requirements, and be capable for base load or load-following operations. Now, a number of avenues aimed at developing suitable plant designs are being explored, and the general approach being taken is summarized here in this table. There are a number of possible applications for such plants. They could be used to provide reliable, affordable power in remote or off-grid locations, or they could provide backup when input from intermittent renewables was lacking and help balance the grid. This would help reduce the cycling of any larger coal plants operating on the same grid, allowing them to continue operating efficiently. The current DOE program is addressing various related issues, and an important one of which is obviously the role of modular design and construction. And, as with other types of plant, shop fabrication and replication could provide multiple benefits such as better quality, fast assembly, the opportunity for pre-testing, and even the possibility of adopting mass production techniques. Now, what sort of market potential are small modular plants such as these likely to have? Well, given the current market conditions, their potential in the USA appears to be somewhat limited, at least in the short term. However, they could prove to be an attractive option, particularly in, for example, some developing economies or places that are just too remote to connect to a national or regional grid. In fact, there are many such situations where access to a reliable, affordable supply of electricity is lacking. For example, if you look at parts of Africa, many regions continue to suffer from extreme energy poverty. It's estimated that possibly up to 640 million Africans are still without a reliable source of electricity. Something in this day and age is viewed as a necessity for meeting even basic human needs. But of course, it's also needed to drive economic development. Africa as a whole has significant coal resources, and potentially it's likely that some of these could be tapped as fuel for small modular power plants. At the moment, coal-based power is being viewed increasingly as an attractive option, and quite a few African governments are actively incorporating its use into their future plans and policies. Potentially, a significant market could open up for small, cost-effective modular plant designs coming out of the DOE program. So where are we at the moment? Well, at the outset, the DOE received 30 responses from equipment suppliers, technology developers, universities, energy associations, and utilities. Early-stage technology design proposals have been requested, and it's expected that several options will be selected for further development. The DOE anticipates that suitable plant designs and cost estimates should be available within a few years, with the first plant designs being available probably by about 2022. Now, just to summarize things and bring them to a close. Well, modularisation is well accepted by the energy sector, and indeed now forms an important element in the design and engineering in general. Its use can allow plants to be built faster, cheaper, and of better quality. And this is particularly true when it's combined with the use of standardised design systems and components. So what's been driving this process forward? Well, historically, much of the impetus has come from technology developers and EPC companies themselves. Although, as we've just heard, the USD area is now actively engaged in this area. In recent years, many technology providers and developers have been operating in a tough marketplace, and this has led to the adoption of many cost-saving exercises, one of which has been the greater uptake of modular techniques. Even though the extent of this can vary widely between projects and the pluses and minuses need to be considered carefully for each, it can often provide significant technical and financial benefits. Although there can be some disadvantages, these are often outweighed by the benefits. In reality, all new plant designs are likely to feature modularisation to some degree. And in addition, novel designs are also likely to open up new market applications and continue driving development further. So to close, well, modularisation, especially when combined with other factors, appears to hold significant further potential for the future. Improvements continue to be made in the design and manufacturing techniques, and there's a growing awareness of the benefits it can provide. Wherever possible, engineering and industry in general, and that clearly includes the power sector, is moving more in this direction. And this gives the benefits, given the benefits it can provide, this is a trend that seems set to continue. That brings us to the end of today's webinar. Now, let's see if there are any questions. So we have one here. You mentioned about modular systems being used for emission control. What's the situation regarding CO2 emissions from power plants? Yeah, good question. Well, as I mentioned in the webinar, modular design and construction techniques are often applied to various types of systems used to control plant emissions for the usual conventional pollutants, if we can call them that. As we mentioned, SO2, particulates, and so on. You might expect there's clearly interest in reducing CO2 emissions from coal-fired power plants around the world, and this is an area where some interesting new techniques are being developed. Some of these are further developments coming from, for example, natural gas processing, whereas others are based on more novel ideas and concepts. Just like some of the other emission control systems we've spoken about, modularisation can be very useful, and potentially it can provide many of the advantages we've already talked about today. In fact, in terms of CO2 capture, we've now advanced to the stage where a number of technology developers are in fact offering complete modular carbon capture systems. This is on a commercial basis, and these plants come with complete with process performance guarantees. But having said that, there's also other work alongside this with various modular or part modular systems being tested at laboratory and pilot scale. I get the sense this is only going to increase with time. We have one other question. You mentioned that manufacturing a dedicated workshop can provide some benefits, which we've talked about. What do you consider to be the main ones? Well, as I mentioned during the webinar, it's often much easier to fabricate things in a clean, controlled environment where you're not at the mercy of the weather or other outside factors. This is undoubtedly an important factor in achieving a high standard of quality. If you take welding, for example, something that most forms of fabrication involves, by doing this in a dedicated modular shop, you tend to get better quality. It's also cheaper. It's not unusual for welding in the field to cost perhaps between 2 and 6 times more. Alongside this, of course, it also, by the mere fact of having access to specialized equipment on hand, it also means that production can be faster, and it often requires less in the way of energy resources and so on. It also makes it much easier for modules to be inspected, pre-tested, even pre-commissioned, which means that completed modules often just need basic assembly and connection once they arrive on the work site. And again, this saves time and money. But of course, as I mentioned earlier, the extent of modularisation you can effectively achieve will vary between projects and the individual system that we're actually talking about. Well, there are no other questions at the moment, but anyone has any, please email them directly to me. I'll bring the webinar to a close now. I hope it's been useful, but if you want any further information on what the Clean Coal Centre does, the areas of clean coal technology and associated topics that we work in, what we're engaged in at the moment, or what we've done in the past, please take a look at our website. We've just published our new annual review, which you may also find useful, and this is available in paper form by contacting the Centre directly, or it can be downloaded from the website. Once again, thank you for your attention during today's webinar, and goodbye for now.